You are welcome to my YouTube channel. This is lecture 3 of Mathematical Method 1. Our topic for today is integration. Recall some common integrals. The integral of x raised to the power n dx is equal to x raised to the power n plus 1 all over n plus 1 plus k. The integral of ax plus b raised to the power n dx is equal to 1 over 1 plus n plus 1 ax plus b raised to the power n plus 1 plus k. So and so on and so forth. The integral of sine x is minus cos x, while the integral of cos x is sine x. Now there are so many other well-known integrals which we'll be using throughout the course of this work. Now let's look at some examples. Evaluate the following. A. Integral from 0 to 3 of the function 5x cubed minus 3x plus 6 dx. B. Integral of sine square x dx, integral of sine cube x dx, and integral of cos cube x dx. Solution. For A, integral of 5x raised to the power 3 minus 3x plus 6 dx is equal to, you integrate them component by component because integral of the sum is the same thing as the sum of the integrals. So for this component 5x raised to the power 3, the integral is 5 over 4 x raised to the power 4. While for minus 3x, the integral is minus 3 over 2x squared. Then for 6, the integral is 6x plus the constant of integration. See, thus this integral over 0 and 3, anywhere you see x, you replace it with 3. Then you subtract it from anywhere you see x, you replace it with 0. Now at the end, you're going to get 443 over 4 as the solution to A. Now for B, integral of sine square x dx. Now there are so many ways to do this, but for now, let's look at direct integration, and that will give us 1 over 2 integral 1 minus cos 2x dx. Knowing that cos 2 theta is equal to 1 minus 2 cos square theta. This is trig identity. So when you do that properly, you're going to have 1 over 2 in bracket x minus sine 2x over 2, because integrating 1 will give us x, with respect to x will give us x. Then while integrating cos 2x with respect to x will give us sine 2x over 2. Now this is the final answer. We are looking at C. Integral of sine cube x dx is equal to integral of, you break it up into two factors, sine square x times sine x, okay, which is still equal to sine cube x. Now after reducing it to a smaller term that we can handle, then we'll pick them up bit by bit. Now the integral of sine 2x sine square x will be the same thing as integral of 1 minus cos square x. And when you do that properly, you have integral sine x dx minus integral sine x cos square x dx after expanding and opening up. Okay, now the final result will give us minus cos x plus cos cube x over 3 plus k as the final result. Then for D, we are integrating cos cube x dx. It will be equal to, you also reduce it from power of 3 to power of 2 to smaller chunk that we can handle. Now when you do a similar thing we did earlier, you're going to have that the integral of 1 minus sine square x cos x, using some trig identities here to replace it. So when you open up the bracket, you're going to have integral cos x dx minus integral sine square x cos x dx. And when you do the integration properly, you're going to have sine x minus sine cube x over 3 plus k. Let's look at another example. We should evaluate the integral of sine cube theta over 1 minus cos theta d theta. In this problem, the solution is simple. Just like what we did earlier, we are going to look at the numerator and reduce the raised to power 3 into raised to power 2 or 2 factors, and this is what you have. Then you integrate them component wise, replacing the first with an identity. Remember this identity, which says that sine square theta plus cos square theta is equal to 1. That is where we got this identity from. Now, after replacing the identity and factoring out and simplifying, we are going to have that the equation will be equal to the integral of 1 plus cos theta sine theta d theta. Now, you open up again the bracket, you're going to have integral of sine theta d theta plus integral of cos theta sine theta d theta. So integrating component wise, you're going to have integral of sine theta is equal to minus cos theta, while integral of cos theta sine theta with respect to theta is sine squared theta over 2 plus k. Now let's look at this example again. Find the integral of 2x cubed plus 1 raised to the power 7, then s squared dx. This is a product. So solution, you say let u be 2x cubed plus 1 and du dx with respect to x will now be 6x squared. Yes, then the integral of 2x cubed plus 1 raised to the power 7x squared dx will finally be rewritten as the integral of u raised to the power 7 x squared then du over 6x squared. Now we factor the 1 over 6 outside and you're going to have 1 over 6 integral u raised to the power 7 du. Okay, because s squared will cancel s squared and this is what will now remain. When you now take the integral, you will now have u raised to the power 8 all over 8 times 6 plus k. Don't forget our u was assumed earlier, so when you replace that, you now have therefore the integral of 2x cubed plus 1 raised to the power 7 x raised to x squared dx is equal to 1 over 48 in bracket 2x squared plus 1 raised to the power 8 plus k. That is the final answer. Yeah, let's look at more examples, more worked examples we have. The familiar, the more you try to understand the different ways questions can be asked. Let's look at this example. We should evaluate the integral of x cube root of 7 minus 6x squared dx. Here, you're going to say let u be equal to 7 minus 6x squared and du dx is minus 12x. So you're going to have minus 1 over 12 the integral of u raised to the power of 1 over 3 du after simplification. And when you carry out the integral, you're going to have minus 1 over 12 times 3 over 4 u raised to the power 4 over 3 plus k. And when you simplify properly, you're going to have minus 1 over 16 u raised to the power 4 over 3 plus k. And our u from the assumption is 7 minus 6x squared. So you put it back here and you have minus 1 over 16 in bracket 7 minus 6x squared raised to the power 4 over 3 plus k. Another example here, say evaluate over the range of 2 and 10 of 3 over square root of 5x minus 1 dx. Solution, let u equal to 5x and du dx equal to 5. So the integral from 2 to 10 of 3 over square root of 5x minus 1 dx will give you the integral of 2 to 10, 3 u raised to the power minus 1 over 2 du over 5. Now, when you simplify properly, you're going to have 3 over 5 integral going from 2 to 10 of u raised to the power minus 1 over 2 du. Now, when you take this integration now, you're going to have 3 times 2 over 5, u raised to power 1 over 2 plus k, knowing that our u is 5x minus 1, so you put it back and take it over the range of 2 to 10, meaning anywhere you see x, you put 10, then minus anywhere you see x, you put 2. Now when you do that and simplify properly, you're going to have 24 over 5 as the answer. Now, application of definite integral. We are going to look at definite integral is used for solving a large variety of applied problems, such as area, volume, liquid force, length of curve, work, and some problems from economics, biology, physics, and engineering. So we are going to look at some examples. Here, we should find the area of the region bounded by x-axis and the graph of f of x equal to x squared minus 1 over the range of x going from 1 to 2. Now, in this problem solution, you say area equal to, you take the integral from 1 to 2 of x squared minus 1 dx. And when you do that over the interval 1 to 2, you're going to get 4 over 3. Okay. Now, looking at the intervals again, thus f at 1 will give us 0, while f at 2 will give us 3. So this information will guide us to plot the graph and shade it. So this graph represents the graph of f of x equal to x squared minus 1 over the interval of 1 and 2. The blue part is the shaded region that we are making reference to. Let's look at another worked example. Should find the area of region bounded by the graph y equal to x squared minus 3x minus 4. Solution. We find the x-intercept by setting the function equal to 0. Solve for x. Now, y is equal to 0 here implies that x squared minus 3x minus 4 is equal to 0. And when you carry out your factorization of quadratic equation, you're going to have that x is equal to 4 and the x is equal to minus 1. So it's closed interval minus 1 and 4. So I've already gotten the solution. So here area is equal to the integral over minus 1 to 4 of minus y dx. And this is equal to the integral of minus 1 to 4 of minus x squared plus 3x plus 4 dx. Now over the interval of minus 1 and 4, you are going to have 125 over 6. Thus, f at minus 1 is 0 and f at 4 is 0. So this shaded portion is the graph of y equal to x squared minus 3x minus 4. Now let's look at this worked example. Find the area of the region bounded by the graph of f of x equal to 3x cubed minus x squared minus 10x and g of x equal to minus x squared plus 2x. Solution. Let f of x be equal to g of x, meaning 3x cubed minus x squared minus 10x is equal to minus x squared plus 2x. Now when you collect like terms and simplify, we are going to have 3x in bracket, x plus 2 and x minus 2 equal to 0. And hence our x is equal to 0, minus 2 and 2, which implies that f at these different points of 0, minus 2 and 2 will give us minus 8, then 0, 0, 0 everywhere. So f of x is greater than g of x on this interval minus 2 and 0. Second graph. Actually, we need this information to plot the graphs. So at the interval 0 and 2, everything is all 0, 0, 0. Therefore, our area will now be over the interval of minus 2 to 0, then 0 to 2. Okay. Now, when you do that properly, you're going to have the integral of minus 2 to 0 of 3x cubed minus 12 dx plus the integral of 0 to 2 of minus 3x cubed plus 12x dx over their respective intervals, and that will give us 24 square units if properly simplified. Now this shaded portion is the area we are talking about, which is the graph of f of x equal to 3x cubed minus x squared minus 10x. While the red, the one painted in red, is the graph of gx equal to minus x squared plus 2x. Multiple integrals. Most integrals considered are of the form single integrals, where f is continuous over a closed interval. We shall consider other integrals like the double, triple, surface, and line integrals in this section. Now, this is double integral, where you have to integrate twice. Now, it's actually similar, the properties are similar to that of single in integrals. Okay. Now, these are the properties. Let's take some worked examples. We should evaluate integral of minus 1 to 3 and integral of minus 1 to 2 of 3x plus 4y squared dy dx. So solution here, you're going to integrate them term by term. The first integral, after doing the integral the first time, then you do it the second time. That is just it. So separating using bracket, you have the integral from 1 to 3 in bracket open and close of the integral of minus 1 to 2 of 3x plus 4y squared dy. So I will do this one in bracket first before the other integration. So when you do that properly, you're going to have the integral of 1 to 3 of 3s y plus 2y squared s squared over the interval of minus 1 to 2. And when you do the substitution properly, you're going to have the integral of 1 over the interval 1 to 3 of 6x plus 8s squared plus 3x minus 2s squared dx. And when you collect like terms and simplify, you're going to have the integral of over the interval 1 to 3 of 6s squared plus 9x dx. Now, you now do the last integration, and you're going to get 180 divided by 2, which is 90. Now let's look at more worked examples. We should evaluate the integral of 0 to 1 and the integral of 2y to 3y of x squared y plus 3y dx dy. Solution. Let this double integral be equal to the integral of 0, 1 in bracket, the integral of 2y to 3y x squared y plus 3y dx, then dy. So you integrate first with the s with respect to x, then integrate lastly with respect to y. So when you do it properly, this is what you're going to have. The integral of 0 to 1 all over x cubed y over 3 plus 3yx over the interval 2y to 3y dy. Now, when you continue with the simplification and collection of like terms, you're going to have the final integral to be integral over 0, 1 of 19 over 3 y raised to the power 4 plus 3y squared dy. Okay, over the interval of 0 and 1, you're going to have 34 over 15. I have other worked examples. Should evaluate over the interval 0 to 2 and over the interval 2 minus x over square root of 4 minus x squared y dy dx. Solution. Let this integral 0 to 2 and the integral of 2 minus x to square root of 4 minus x squared y dy dx is equal to the integral of 0 to of the integral of 2 minus x over square root of 4 minus x squared y dy dx. Now, This integration of 0 to 2 will give us a squared y squared over 2 dx. And when we continue with the simplification, we are going to have 2x raised to the power 4 over 4 for the interval of 0 to 2, and this will give us 8. Okay. Now let's look at other worked examples. Multiple integral. We should evaluate the integral of 0 to pi over 4 and the integral of y to pi over 2 minus y of sine x plus y dx dy. Solution. Let the question be equal to integral of 0 to pi over 4 of minus cos x plus y over the interval of y to pi over 2 minus y dy. Okay, so when you do the evaluation properly, you're going to have the integral of 0 to pi over 4 cos 2y dy. So integrating this over 0, the interval 0 and pi over 4 is going to give us 1 over 2. Thank you very much for listening.